In this video, I'm going to give you a quick introduction to the idea of a limit. And the good thing about limits is that they are pretty intuitive. So first off, we have to be able to read a limit. There are two parts to the notation. The first is that red box and the second is that green box. The part that's in the red box here is a function. So this would be the limit of some function. Now, that function can be written as a function like f of x by name. It can be written as an expression like x squared over x minus 5, something like that. You can see those are the two different things you can see in that space there. And then in the green box, you have to be given a specific x value, and it looks like this. It's x with a little arrow next to it, and then some number or constant. And the way we would read this is the limit of whatever our function is, x squared over x minus 5, as x approaches 4. That's how the language works. So anytime you see notation like this, the limit of x squared over x minus 5 as x approaches 4. The order isn't as important. You know, the fact that we say the function first and the approaches second, that's not as important. But the words of and as are incredibly important here. It's the limit of whatever that function is as x approaches some number. Now that we can read it, we've got to talk about what it actually means. It's a nice, simple little idea. The limit of a function is some y value that the function gets infinitely close to when the x is close to a. So if I take a look at a graph here, just an example of some function, I'll put the function in red. And I'm going to put some x value here in green. I'm going to give it the name a, just to stand for some number there. The limit would be this y value right here, that as the x value is close to a, and one way we often describe it is as the x value gets closer to a from both sides, the y value of the function, or the output of the function, is getting closer and closer and closer to whatever this little dot is right here, whatever this y value is right here. So that's the idea of a limit. In this example, it's a little bit silly because the value of that function when x was a was just L, was just that number. But what's useful is for functions that have holes in it, or some other situations we'll see during the year where you might not be able to find out what the function is equal to when x is exactly a. But we often want to know what x is getting really close to what the function is getting really close to when x is close to a. A quick important note here. We'll talk more about this in just a second. This y value, that L, is only the limit of the function as x approaches a if the function gets close to the same y value on both sides of a. We'll talk more about that in a second. So first off, you can often estimate a limit numerically or graphically. So here's an example of a function, same one I mentioned before, x squared over x minus 5, and we're talking about as x is getting close to 4. So we can do two things. Number one, we can look at the function. I know the window is a little bit weird right now, but you can see the x value here is 4, and you can see that the function is getting closer and closer and closer to what appears to be negative 16. So that's one way to estimate a limit, just by looking. Or we can make a table of values and see that as x gets closer and closer and closer to 4, 3.9, 3.95, 3.99, we see our x values getting closer to 4, and we can see these y values getting very, very, very close to negative 16. But importantly, we have to make sure that it is happening on both sides. So I have to make sure that when x is getting close to 4 from above, so 4.1, 4.01, 4.001, we see here that the y value is getting closer and closer and closer to negative 16 there too. And so that's how we can check to make sure to estimate what the value of a limit is. If the y value is not getting close to the same thing on either side, such as in this example, we have a slightly different notation to use. These are called one-sided limits. So this is my function f of x. Notice how it's that red function, even though there's a break in it, it's the same function throughout that entire domain. The limit of this function as x approaches 3 doesn't actually exist. The y value isn't getting closer and closer and closer to any one thing, because here it's getting close to 3, here it's getting close to 1. So we would say that limit does not exist. Sometimes you can say dne. But sometimes we don't need to know what's happening on both sides. Sometimes we only care about what's happening from one side. So let's say we only care about what's happening as x approaches 3 from the right. Well, we do have a notation for that also. We would write the limit of f of x as x approaches 3 from the right. We put a little plus sign as a superscript, kind of where the exponents usually go, next to that 3, and we read that as from the right. And we can say the limit of f of x as x approaches 3 from the right appears to be 1. And the limit of f of x as x approaches 3 from the left, put a little minus sign to show it's coming from the left-hand side, that looks like it's equal to 3. So these are 3 different limits, all in the same function of the same x value. Just a little bit of differences in notation make a big difference in what those words mean.